Hello my dear students, welcome back to AriserTalent. I am your maths teacher Arpita Sharma and today we are going to start the exercise part of our chapter. First we have completed the theory, now it's time to do some questions on the theory, right? So here is our exercise 1. Okay, so here are the questions of the exercise and we will deal with the question one by one here in this part. Okay, so the question number 1 is 0 a rational number? Can you write it in the form p by q, where p and q are integers and q is not equals to 0? That means it's saying about 0. Now student, look here, 0 is a rational number or not? A rational number that can be written as p by q format, where q should not be equals to 0 and p and q should be co-primes. P and q should be or must be co-primes. Okay, so 0 can be written as, or I can say 0 equals to 0 by 1, 0 by 2, 0 by 3, 0 by 4. Now these all can be written as p by, these all are in a p by q format. Now 0 and 1 are co-prime, 0 and 2 are co-prime, 0 and 3 are co-prime, 0 and 4 are co-prime. Now p and q are co-prime and q denominator is here nothing like 0. So I am fulfilling both the two objectives, that p and q are co-prime first and q is not equals to 0 and p and q are integers also. Okay, so three conditions are fulfilled, that means this is a rational number. So yes, 0 is rational. Why? Because we have proved that. Okay, we have find out. Now the second question, find 6 rational numbers between 3 and 4. In the second question you have to find 6 rational numbers between 3 and 4. Now come here about the question number 2. How will you solve it? It is very obvious to solve, that we have to find out rational numbers between 3 and 4. Right, rational numbers between 3 and 4, how will you find it? You will find the method of denominator. You can also find with method that mean method, okay, but we are here applying denominator method. What is the denominator method? How many numbers we have to insert between these rationals? That is 6. So denominator equals to 6 plus 1, that is equals to 7. So now 3 equals to something divided by 7 and 4 equals to something divided by 7. This is about the denominator. Now what is divided by 7 equals to 3? 21 by 7 is equals to 3. Simple. 21 by 7 equals to 3. Now what is 4 divided what is divided by 7 is equals to 4? Simply 28 divided by 7 is equals to 4. Now we have to insert how many numbers? 1, 2, 3, 4, 5, 6. 6 numbers we have to insert between them. Okay. Right. So that will be after 21, 22 come, 23, 24, 25, 26 and then 27. Simply you have to insert this 7, 7, 7, 7, 7, 7. So 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7 is your answer. These are the numbers, that is number 1, 2, 3, 4, 5, 6, 6 numbers between 3 and 4, right? Okay. These are all rational numbers. So this is about the first and second question. I am rubbing this question number 1, hope you have copied it, okay. And just copy this question number 2 also, I am going to rub this also. Copy this, okay. So we have deal with the question number 1 and question number 2. Now question number 3. We are talking about question number 3 here. So question number 3, find 5 rational numbers between 3 by 5 and 4 by 5. So the numbers are here, rationals between 3 by 5 and 4 by 5. How many? 5. Okay. So in that case, what will you do? You will say that, ma'am, in this particular thing we are already having this denominator thing here. So how will be converted something other than this? Okay. So we are clearly have to give 5 numbers between them. What can be done? What can be done that we are having this 3 by 5 and we are having this 4 by 5. Now multiply these with 10 and you will get 30 by 50. The same will be the value here, 3 by 5, this is, and the value of this will be also 3 by 5. Okay. That will be, after doing that, that will be 40 by 50. Now you are having the same base is equals to 50 here and base equals to 50 here. So denominator is same. So now you have to insert between 30 to 40 some 5 numbers, any 5 numbers you can pick. Any 5 numbers you can pick. Okay. So the numbers will be how many numbers? 5 numbers, right? 5 numbers. Okay. So 1, 2, 3, 4 and 5 numbers you have to fill in. Okay. So that will be after 30, there will be 31 by 50, 32 by 50, 33 by 50, 34 by 50, 35 by 50. That will be your answer. Now you will say, you will ask me, ma'am, can we write 36 by 50? Yes, you can write, but we have asked only about 5 numbers, so we can choose any 5 numbers between among these. So these are the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. These 9 numbers are there. You can pick any 5 numbers from these 5 numbers to be as your answer of your choice. Okay. This is your answer in a textbook, but you are not you are not very bounded by this answer. You can have this and particular this and this number also. You can pick any number, but we are just following the hierarchy, something like first 5 numbers. You can take the last 5 numbers also. You can pick random numbers from in between. Okay, you can do that also. So this is the answer number 3. Done with that now? Okay. Look at the question number 4. State whether the following statements are true and false. Now this particular question we have done earlier too. Every natural number is a whole number. Every natural number. So I am talking about the 4th one. In the first, it is saying that every natural number belongs to a whole number. In the second, it is saying that every integer is a whole number. In the third, it is saying that every rational number is a whole number. Okay. So come here. What it is saying, every natural number is a whole number. Now what is natural number? Natural number is 0, sorry, not counting numbers only, 0, not 0 but 1, 2, 3, 4, 5 and so on till n. So this is the set of natural number. Now whole number set is, if we are including 0 in this number set, so till n, that will be whole number. Okay. Now every natural number, 1 is whole number, right, 2 is whole number, right, 3 is whole number, right, any number from n is whole number, right. So that means this is true. True it is, that yes, every natural number is a whole number. Now the next one, every integer is a whole number. Every integer is a whole number. Now the set of integers is what? From minus n to minus 3, minus 2, minus 1, 0, 1, 2, 3 until n. So this is your set of integers. Now whole number is 0, 1, 2, 3, 4 and so on till n. Now students, now you can clearly tell me that madam, minus n is here, minus n is here in this set of integer but not in this whole number. Minus n, minus 3, minus 2, minus 1, these all are there in the set of integer but they are nowhere in the set of whole number. That means some integers are there that are not belongs to the whole number set. That means this is completely a false statement. This is false. This is false. Now the third number. Every rational number is a whole number. Every rational number is a whole number. Now what is rational number? Rational number is a number that can be written as P by Q format. Now if I talk about whole number is again 0, 1, 2, 3, 4, 5 and so on till n. Okay, if I talk about rational, all these are rational number, no doubt. But if I am talking minus 3, which can be written as minus 3 by 1, it is not a whole number. It is not a whole number, but it is a rational number. That means every rational number not necessarily be a whole number. It may or may not be a whole number. That means this is again is a false statement. Understood these things? Understood these all complete questions? Okay, so note them and then we are going to move forward to our next question. Noted? Also note the questions also. You will be finding them in your textbook, but anyhow you can just take a snapshot or you can just write in your notebook, right? Now we are having this exercise 1.1 is finished. We are moving towards the exercise number 1.2. Now in the first question of this this exercise 1.2, we are having state whether the following statements are true and false. Again we are having this true and false, and in this situation of true and false statement, you have to be very specific. You have to just put some situation that is it true, is it not. So it's little bit confusing, but you have to focus on that and find out that what is right and what is not. Now state whether the following statement are true and false. The first wise statement is every irrational number is a real number. Okay, so I am talking about the very first question here. In this, the first and second two parts are there. Every irrational number is a real number. Okay, the second is every point on the number line. Every point on a number line is in the form of root m, where m is a natural number, where m is a natural number. Okay, then every real number, third one, every real number is an irrational number. Every real number every real number is an irrational number. These are the 3 points in which we are talking about. Okay, so moving towards our first one, which is every irrational number is a real number. Now it's saying every irrational number is a real number. Now when we started this chapter, in the first lecture, I have told you that we are having real numbers and we are having imaginary numbers, and I have told you that we are not going to talk about this imaginary number, but we will be talking about real number of two types, that is rationals and irrationals. Rationals and irrationals. Now students, we have represented it, the irrationals also on the number line. Okay, beside that we are saying here that irrational number having two parts, rational and irrational. So yes, every irrational will be a real number for sure. That means this is true. Why? Why? Because it's a part. It's a part. Real number. This is not R. That is this is rational numbers. Okay. This is real number. Okay, real number. So yes, it is, because real number having two parts, rational and irrational. So simply it is true that every irrational number is actually a real number. Now the next thing is telling us that each and every point on the number line is root m when m belongs to a natural number, when m belongs to a natural number. Now we are on the number line having, on the contrary, we are having number line 0, 1, 2, 3, 4. Now again here I am having -1, -2, -3, -4. Now if I am talking about root m, listen to me, if I am having root 1, its value is 1. If I am talking about root 2, its value will be something 1.414 something. So it is positive in case. Okay, root 3 will be having what? Any number which is positive. Root 4 will be having value 2. Root 4, root 5, root 6. That means all the values of root in a natural number will be giving a value is equals to positive, but we are having also negative numbers on our number line. So these values are not defined by this. So that means it is true, this particular first one was true, but in this case this is completely a false statement. Why it is false? Because it is not defining this -1, -2 and so on, the negative integers or the negative, all the negative numbers on the number line, that cannot be defined. Okay, so this is wrong. Now real number, all the real numbers belong to irrational. Every real number is an irrational number. Every real number it is talking about. Every real number is an irrational number. Is it possible? Because if I am telling about root 1, so the value will be 1. If I will be talking about root 2, so the value will be 1.14 something like that. Value root 3, the value will be something positive. Okay, I will tell you about the root 4, the value will be 2 here. Now value of root 4 is 2. Root 2 is what? Rational. Root 2 is rational, sorry, root 4 is rational. If I am talking about root 1, this is also rational. So this is on contrary, that every real number is an irrational number. Every real number is an irrational number. This is wrong, because we are having 1, 2, that is the value of root 4 and root 1. Okay, so this statement is also very false. Okay, so that means every real number is not an irrational number, because we are having real numbers like 2 is not irrational. We are having numbers like 1.41. Now it is in decimal, but it is again not irrational, but it is real number. So every real number may or may not be an irrational number. Okay. Now, are the square roots of all the positive number irrational? Are the square roots of all the positive number irrational? If not, give an example of the square root of the number that is rational number. Are the square root, that means if I am taking the square root of positive numbers are 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, I am taking these. Okay, this is irrational. Now this is 2. It is irrational, it is rational. Now root 1 is also what? 1. So here it is 1, it is 2. That means root of positive numbers may be rational as well. Root of positive number may be rational as well as. So that means what will be the answer of the second question? Are the square roots of all the positive number irrational? No. No, simply no is the answer. Now, if not, give an example of a square root of a number that is rational number. Root 4 is equals to 2 and 2 is rational number. This is first case. again you can write that root 9 is equals to 3, and which is again an irrational, sorry, a rational number. Right. So, understood these 2 points. Okay. Now, third, how root 5 can be represented on number line. Okay. Copy these, then we will move forward to root 5. Now, how will you represent root 5? I have told you, you can make a line that will be 0 and that will be 1. You will use your geometry box for that. This will be equals to this unit and unit. Okay, you will meet these points, you will get this as root 2. Now, you are having this, you will make perpendicular here, this is of unit length. Okay, now that will be root 3. Now, again you will be making the perpendicular here of unit length, and you will be meeting these, that will be root 4. Again you will be taking this as perpendicular, okay, and of unit length, I will be meeting this to that. Now, that will be root 5. Now, students, this particular length is root 5. So, what we will do, you will be having this point here and have an arc equals to this length and cut it here, and that value will be what? Root 5. Okay, this is your solution number 3. Now, we are now discussing this question number 4th. Construct a square root spiral. Construct a square root spiral. This is what? The same we are drawing here. If we will exceed this to root 6, then root 7. So, the pattern will be something like this. Then. Okay. So, this will be the spiral, like then again then. So, that will be the geometry of this construction, and you will be having root 6, root 7, root 8, root 9 here also, and that is our square root spiral. So, just try it here. So, I am just concluding my lecture, in which we have covered 2 exercises, exercise 1.1 and 1.2. In our next lecture, next session, we are going to cover the next exercises of our first chapter. Okay, take care, bye bye.